and let us start the next session where I will kick off and will be followed by a presentation by Emile De Lange and Jocelyn Shea. Thanks to my co-organizers for volunteering me to present my work in progress entitled Development, Economic Growth, and Species Endangerment. You will notice that it is early stage work, so I look forward to all of your comments and suggestions. So instead of repeating myself with an introduction slide on the importance of biodiversity, I thought it may be nice to show some pictures of what biodiversity means to me. Well, since about a year, my wife and I have a little garden here in Mexico. And while I've enjoyed my encounters with a pair of pygmy skunks, a couple of snakes, and the occasional iguana, I'm often most surprised by the variety of insects. On the days that I spotted a praying mantis or stick insect, I was just as excited as seeing a species of bird or a reptile for the first time. I also like caterpillars a lot because they come in all sorts of shapes and disguises. And also because they don't run away or fly away so fast for the photo. Many of them are hairy, very hairy. And the one is even looking even more mean than the next. Yet not all of them grow up to be Darth Vader. Some of these scary caterpillars turn into the most beautiful butterflies. The caterpillar season only means that I need to be a little bit more careful when recording my presentations. And talking about my presentations, let's get back to the paper. Well, there is little debate over the direct drivers of biodiversity loss. The influence of economic growth and GDP per capita on biodiversity loss is more debated. The debate seems to revolve most prominently around the environmental Kuznets curve hypothesis, which predicts that pollution first rises with income, but at some turning point income level, that further growth will lead to environmental improvements. My reading of this environmental Kuznets literature is that there is some evidence in line with the hypothesis for local air pollutants, such as silver oxides and particulate matter pollution. However, that in general, the environmental Kuznets curve hypothesis seemed to be rooted mostly in wishful thinking. For example, in a meta-analysis of over 500 estimates from some 70 different studies focusing on deforestation, Schumert et al. Find that the more recent the year of the publication is, the more likelihood of having an environmental Kuznets curve declines. In my 2019 publication in Ecological Economics, I had used ordinary least square regression analysis to explore the association between species endangerment using IUCN red list data and regional GDP per capita. I found that species endangerment increases with GDP per capita after controlling for some regional observable characteristics. And I found no evidence of an environmental Kuznets curve. The paper that I present here today builds on this work that I've published in 2019. Let me briefly explain how I used IUCN red list data to express assessments in expected extinction rates. Several species assessment categories, such as vulnerable, endangered, and critically endangered species, come with a probability of extinction within the next decade or century, depending on the category. I wish to express the assessments in expected extinctions relative to the background extinction rate to make the regions more comparable to each other and to studies on planetary boundaries. For background extinction, I took the upper bound estimate of 1 extinction per million species years from Rockström et al. The planetary boundary as expressed by the same authors is set at 10, and later Stefan et al. Added the zone of uncertainty up to 100. The map shows that slightly half of global landmass and all oceans face expected extinction rates that exceed the planetary boundary beyond uncertainty. You can also think of the map as showing a weighted average of IUCN assessments where critically endangered and endangered species receive higher weights. The map illustrates that one finds the highest extinction rates in tropical regions and on islands. My map also suffers from a form of map distortion due to the double counting of species with large ranges. Species with large ranges are also less often endangered, and therefore the average regional extinction rate is at 190 times the background rate, while the global extinction rate is about 750 times the background rate under assumptions spelled out in the paper. The work that I present here today is inspired by this map distortion. Instead of organizing my data by region, I chose to organize my data on the species level and focus on a set of relatively short-range species that are endemic to only one region. For this paper, I decided to organize my data on the species level. I inspected nearly 10% of the 2019 IUCN Red List and chose to include in my sample only small range species that are endemic to one of the regions as indicated by the IUCN. For these endemic species, I created 2 dummy variables, threatened and decreasing. Threatened was available for a little over 3,500 observations and takes the value 1 for categories vulnerable, endangered, and critically endangered, and 0 otherwise. Decreasing equals 1 for species with a decreasing population trend and 0 otherwise. Subsequently, I matched the species assessment variables to regional GDP data and other controls used in Sol 2019. My sample of short-ranged endemic species consists of mammals and plants only, where I inspected all mammals in the IUCN population except for the order of rodents, and all plants except for the Magnoliopsida class. My sample of endemic species is more endangered than the IUCN population. For example, 70% of plants in my sample are endangered as compared to 40% in the IUCN population. I chose to focus on endemic species to prevent this issue of double counting, and arguably the analysis over the subsample of endemic species is less sensitive to regional spillovers. Similarly, one could argue that my sample consists of a set of species that is more sensitive to regional policies. However, it is also good to keep in mind that my sample restrictions lead to certain taxonomic groups being better represented in my sample than others. Moreover, my sample restriction criterion is sensitive to the regional division of the IUCN. As you can see, it led to a high concentration of observations from only a few regions. Possibly you may wonder why, for example, Borneo is missing from this top 10. And this is because the IUCN data considers Kalimantan, Sabah, Sarawak, and Brunei Darussalam as separate geographic regions. There are species from 263 regions in my sample, yet half of the observations come from this top 10 regions. The results that I show here today are robust to excluding these 10 regions from the analysis. Here I show the results from an OLS regression based on the analysis with small range species. Species endangerment decreases with GDP per capita. And endemic species, their populations show fewer decreasing trends with higher GDP per capita. As GDP per capita is highly skewed, I had taken the natural logarithm first, which means that the doubling of GDP per capita is associated with about 5% less endangered species and about 8% species less species with a decreasing population trend. The results are qualitatively the same for probit and low-hit regressions. You may have noticed that the results that I show here are opposite to what I found in Sol 2019. The association with human population density remains unchanged between the two papers. More densely populated areas are associated with more species endangerment. My best explanation so far for this paradoxical finding of opposite association with GDP is that the association with GDP is estimated over a rather different part of the income distribution. The histograms show that the endemic sample contains more observations from low-income regions. In conclusion, here I've analyzed a subsample of small-ranged mammals and plants that suggest species endangerment decreases with income. In 2019, I found the opposite association for largely the same IUCN data, but organized by region, which resulted in a considerably richer sample. Together, these findings suggest a relation that is entirely opposite to the environmental Kuznets curve, namely one of decreasing impact on biodiversity at the first stage of economic development, followed by increasing species endangerment once some threshold income has been reached. My findings suggest that poverty is more harmful to biodiversity than affluence. I aim to check the robustness of my findings and explore possible mechanisms by adding variables on agriculture, education, poverty, and trade. I'd like to close with backing the call by Hickel et al. And Otero et al. To include post-growth scenarios in future international policy documents for conservation and climate change. These are the references that I used on my slides. Pause if you want to read all. This is what I prepared for today. I'm happy to share the slides or the working paper in case you would like to go over some details again, and look forward to hearing your alternative explanations and suggestions. Thank you for your attention.
I do see a question in the chat, if it's a question on your presentation.
So I see a question by Emil. What about history? Is it possible that richer countries have already seen more extinctions? Is the footprint of affluence always in the location of consumption? So let me take the second question first. Clearly not. And so this is one of the reasons why I wish to include variables on trade in my next revision to check for possible mechanisms. What about history? It is, of course, also very, very plausible that part of the impact is cumulative. And so in this sense, GDP per capita is only a proxy for this historical damage, if you interpret it as such. I didn't look at inequality alongside GDP. This is an excellent suggestion as for next steps. And
Iago also has a question for you, I see.
Please, yes.
Yeah, thanks a lot for the presentation. I was wondering, you said that taking together the two results from 19 and from the current study, you find the opposite of an environmental Kuznets curve. Could you maybe explain a bit how do you arrive to this conclusion when considering the two studies together?
So I agree that this is to some degree speculation, but the speculation is based on on these histograms that I showed, that the relationship between species endangerment and GDP per capita in the 2019 paper is estimated over a different part of the income distribution as compared to this endemic sample, where the species face a much more poorer set of regions. So to complete my line of thought, the increasing impact of GDP per capita that I speculate out of sample here, I speculate based on my findings in the 2019 paper.
Thank you.
You're welcome.
I'm not sure whether there is another question, but as I'm not an economist, can you shortly explain why the Kuznets hypothesis is so important in this respect?
So it is one of the most popular theories or hypotheses that claims a beneficial impact of economic growth on the environment at some point. A similar theory, ecological modernization theory, proposes much along the same lines. And well, so my reading so far of this literature is that it is mostly wishful thinking. Huh?
So it is the idea that through economic progress, through economic growth, nature and the environment will become more and more protected as there is more money available to protect nature systems. That's the idea.
So both because there's more money available, so more means for conservation, but also as countries grow richer, the idea is that leisure in nature is often seen as a luxury good, and so there's higher demand in richer regions. But once again, it sounds beautiful, but there is very little evidence for the environmental Kuznets hypothesis. Only in some local air pollutants, well, local pollutants to some degree.
Can I ask another question about the data?
Sure.
So you analyzed the IUCN threat status data, and indeed, is it so that the threat status also is unequally divided across the world? For instance, in the global north, one may argue that extinctions are much lower because of lower degrees of endemism and higher populations of more common species. Did you kind of look into that aspect?
Yeah. So to comment on this very briefly,
yep.
I include subcontinental dummies. So in a way, the variation in species endangerment and the association with GDP per capita is estimated over subcontinental variation. So this takes your comment into account to a certain degree.
Ah, beautiful.
And
thanks.
Let me not take more time of the next speaker. The double role of moderator and speaker is always a bit shaky, especially if you go first. So please, Emil and Jocelyn, the floor is yours for your presentation. Thank you for your questions and comments.